Okay. Um, Screen record. Where's the screen record? Do you guys see my screen?
No.
No? Wait, stop screen. Oh, I'm screen recording when I do that. Oh, okay. Okay, now you guys see my screen, right?
Yep.
Okay. Okay, let's do this. Gen Chem 2 worksheets. Okay, so I'm just gonna erase some of these things. So one thing you guys need to make sure is you guys are familiar with the reference table you guys still have. Uh, that reference table is what you're gonna have for the exam. Yeah, that reference table is what you guys are gonna have for the exam. So some things and constants that you should know. You should definitely, well, not know, but like know you can find on the reference table is like the KF value. I don't know if the gas constant's on there. I'm pretty sure it should be. That's only for one equation though. Um, yeah, I think that's pretty much that. And then also like the integrated rate laws and stuff. You definitely should have a familiar understanding that that's on the reference table because that'll be important. And yeah, like I said before, this exam was last year's exam. So yeah, there's some questions here that were, yeah, so this exam will probably be around 40 or so questions. Um, yeah, you definitely should have enough time to do all of these questions, but of course, like there's some math questions that can be a little tricky. And so hopefully me going over this will help you like really like hone those skills in. Okay. So let's go over question one. So by the way, I can't see the chat. So if you guys have any questions or any comments, feel free to just shout them out. And yeah, this will hopefully be posted and recorded onto my YouTube channel, which I'll post to you guys. Okay. So the specific series of steps by which a chemical reaction occurs are called, right? So this is just a concept, right? Kinetics is too broad. Catalyst, we know that that decreases the activation energy of a reaction. So when I think of the activation energy, with a catalyst, it will decrease it like that. So like the reactants and products remain the same, but the activation energy decreases, right? So that's not it. Energy diagrams, this is an energy diagram, so that's not a reaction step. It kind of does show steps, but not really. Activation energy we just talked about. So the answer would be E, reaction mechanisms. And that's the thing with the steps where you have like A plus B yields C, and then C plus B yields D, right? Something like that. Okay. All right, let's move on. Which of the following is expected when a sample of sucrose is dissolved in ethanol? Okay, so we know that with this is basically just a colligative property question. So this is something that you need to just have in your head. When like colligative properties happen, like there's a freezing point depression and a boiling point elevation. So decrease, increase, boom, that's it. We don't need to worry about any other questions. Okay. Number three, which of the following decreases the solubility of chlorine gas in liquid hexane? So solubility, so this is with a gas. So solubility, what would decrease the solubility of gases, right? So increasing solubility, you would increase pressure and decrease temperature. That's how you increase solubility. So the opposite is true. So you need to decrease pressure and increase temperature. So let's see. The answer would be C in this case. Oops. All right. Let me know if I'm going too fast or anything. Um, but yeah. So the chemical reaction below is found to exhibit the second order rate reaction kinetics. What is the rate law for the chemical reaction? So remember that there are two ways to figure out rate law. One is through the reaction mechanism, where we know the slowest step, and the other way is do experimentally. So if we have the overall rate reaction, we're not able to figure out these rate laws. So all these answers are wrong. The answer is E. Okay. Number 5. Which of the following statements is false regarding catalysts? So number 1, catalysts decrease in concentration as reactions proceed. This is false. 1 is false. 2 is correct. So I'm just gonna exit. 3 is false, and 4 is correct. So this is right. This is wrong. So right, like what I said, catalysts they create a new reaction pathway, right? So this is like a little mock demo of like a catalyst, right? They decrease the activation energy, causing a new pathway to form, right? It doesn't increase the activation energy. So the answer choice would be A. Okay. Refer to molecules A to E. Okay, so this is you see these molecules all have different functional groups or different things like that. So we're gonna have to ask questions about that. Which of the following is slash are not expected to exhibit hydrogen bonding, right? We see here that um, A has hydrogen bonding and E has hydrogen bonding. Those are the hydroxyls or OHs. Those definitely have hydrogen bonding. So the ones that don't have hydrogen bonding are B, C, and D. So that would be choice D. Okay. Yes, even though like D is a dipole, right? It's not hydrogen bonding in that case. Okay. Rank the substances in order of decreasing boiling point. So decreasing boiling point. So you start off with the highest intermolecular forces and you end up with the lowest amount of intermolecular forces. Okay. So let's look at this. I had a lot of questions about this. So let me know if you guys have questions about this as well. So we see here that A and E have hydrogen bonding, which is the strongest intermolecular force. So it would be E first, then A. Then we see here that D would probably be next because D has a dipole. And then the last thing is that C and B, they're competing with dispersion forces. And we see that C has more dispersion forces than B. And so that's how you do that question. So it'd be D. Okay. So all I did there was just identify the intermolecular forces and compare them based off of like the level of intermolecular forces. We see that E has more sites of hydrogen bonding than A does. Okay. All right. Which of the substances is slash are expected to solely exhibit dispersion forces? So that would be B and C. All right. So every substance here displays dispersion forces. Anything that has dispersion, like anything that has an electrons, displays dispersion forces. However, the only one that has like just solely dispersion forces would be B and C. Because this one, D has dipole, and then E and A have hydrogen bonding. Okay. Which substance is expected to have highest vapor pressure? So highest vapor pressure means lowest intermolecular forces. And so for this case, it would be B. Okay. Which substance is expected to be most soluble in water? This would be E because it has two hydroxyl groups. Okay. So do you see how like all of these questions, if you know the idea of like intermolecular forces and stuff like that's pretty much the way you have to solve all of these questions. So this is a pretty easy question he could ask on the exam, and he has asked it last exam. He asked it on my exam. So just keep that in mind. This is a pretty good amount of questions there. All right. Okay, any questions? I just went through the first page of that pretty fast.
I have a question.
Yeah.
Oh, for number 10, do we choose the molecule that has the most hydrogen bonding?
Yes. Yes. Because they will have more sites for hydrogen bonding with like water or something like that.
Okay, thank you.
Yeah, no problem. Yeah, if they ask a question like which of the following substances would be most soluble in like methane or like hex like a non-polar thing, then you'd have to do like the one with the most dispersion forces. Or actually it would probably be That would be a little bit more tricky. So I don't really think he would ask a question like that. It'd probably be just specifically water. But yeah, because you guys aren't, that's more of an organic kind of question. Anyway, okay.
Could you go
Mhm.
over why four was can't be determined?
Yeah, sure. So is this because there are two ways to figure out the rate law. One is through the reaction mechanism, which is like the steps. So like you do like this, C plus B equals D, right? This is like a reaction mechanism. And we see that this is like the slowest step. So then we can figure out that the rate law would be like rate equals K A B, right? That's one way to figure it out by the like the reaction mechanism and knowing it's the slowest step. The other way is experimentally using the numbers. Um, like you see like three different experiments, and like when you double something, the rate doubles, right? And then you see whatever. If you don't have the experimental data or the reaction mechanism, you're not able to figure out the rate law. So that's like the big idea. Okay, so you need either the experimental data or the reaction mechanism. Does that make sense?
Yep, thank you.
Okay, sounds good. Okay, so now as we go on to 11, we see that we have this phase diagram. So yeah, what is expected to occur when the substance described by this phase diagram is heated from 250 degrees Celsius at a pressure of 10 atmospheres? So we go to 10, right? We go to 250. Okay, we draw like a line like this. Sorry, my handwriting's bad. And we go forward 400 degrees Celsius. So if you recall, right, we said that this is a liquid, right? This is going to be solid and this is going to be gas, okay? So as you go from liquid to gas, what is happening? We see that the liquid is vaporizing. So the answer choice is D there, okay? So you also want to be familiar with the solid, liquid, gases, gas, liquid, solid. And this also demonstrates how vaporization is a endothermic process. So that's like a little hint, right? We know that this is going to take energy, right? And this is releasing energy. All right. So that's like also a little hint for you to like make sure you know what endothermic and exothermic processes are. Okay. If this substance is initially at room temperature, 20 degrees Celsius, so like right here, 1 degree atmosphere, like around here or something like that, what series will allow this substance to sublime? So sublime, okay, you got to make sure you remember how that works. So deposition is when gas goes to solid. That's like when we see frost on grass. Solid to gas would be sublimation, right? Solid to gas, like that. So we want this thing to like essentially go to here, right? And so what we need to do is we need to decrease the pressure and increase the temperature. So let's see if we can find that. So I think A is the right answer, just because this is the only one that says decrease. Everything else says increase pressure. All right. And so that's why I'm going to choose A. Okay. So I'm like going through this a little quickly, but part of the reason why is because I made the answer key, right? So I went through all these questions and I made sure to know whatever. But these sort of like the way I'm explaining it is like how you should try to think about these kind of questions, right? You need to make sure you know the concept of sublimation, then apply it to the diagram, and then see if there's an answer choice that follows that line of logic. All right. What set of conditions are required for the substance to be at the triple point? So the triple point is when all three phases are supposed to be able to exist. So we see that it's around like 1 atm-ish and then like 150 degrees Celsius. And so that answer choice is going to be B. Okay. So again, you just see that like you just make an observation, make an approximation, and that should be around that. I hate this Siri thing on Good Notes. I don't know why it's there. I don't know why Good Notes has an AI. It makes no sense. But anyways, okay. This substance is capable of condensing at 100 degrees Celsius. So condensation is when gas goes to liquid. So at 100 degrees Celsius, is this substance able to condense? No, right? We see that it's not. This line here is just going from sublimation or deposition. It's not condensation. So this is false. Okay. So like, yeah, don't overthink these questions, right? These questions, they give you a lot of room to overthink. Like you could look at this question and be like, oh man, like what the hell is this supposed to mean? But like the reality is that like you just have to apply the concept, be confident that you already know the concept and then be like, okay, this is not a condensation part. Like the condensation would happen between liquid and gas. So yeah, just try to be confident as well because that also is really important. That's a very important test taking skill. Okay. Which of the following is false regarding transition states? So transition states, if I draw up my little reaction diagram, they're right here. They're on the top of these things. They're high energy states. We can see that through this diagram. They're also short-lived, meaning that it's very hard to isolate. I don't know why I put a question mark here. It is hard to isolate. Um, yeah. Yeah, I think the answer is E in this case. Yeah, like that's kind of yeah, but all four of these answers are pretty much true. So gonna put E here. All right, and that's just because like the transition state is not like an intermediate where you have like like a stable state. So intermediates, right? If you look at the reaction diagram, like this would be intermediate, and the reason why it's so low is because it's stable, right? And it forms an actual like compound that you could probably isolate a little bit. And so with like the reason why they're stable is because of like the fact that they're in a state in which the bonds are like kind of broken and the bonds and the product are kind of partially. It's like very hard to explain, but I think D does a good job with that. So yeah, the answer choice is E in that case. Okay. For 16, for which of the following substances is it reasonable to expect a experimental observed Van Hoff factor of 2.8? Okay, so that means that we would have to have like a ionic compound here that has around 3. E does not make sense. It's a non-electrolyte. This is 4, this is 4, this is 2, and then this is 3. So I would say A would make the most sense. Okay, let's move on. Um, yeah, compared to pure water, a 0.100 molar substance, a solution of magnesium chloride will have a lower freezing point, higher boiling point, and lower vapor pressure. Yeah, the answer choice is A. Okay, because this is the same thing with colligative properties, right? Freezing point depression, boiling point elevation. Yeah, let me just write it like this. FP, BP, and then VP is also decreasing. When intermolecular forces increase, vapor pressure decreases, all right? So you want to also like one thing I would highly recommend is just like make sure you try to remember these relationships that I'm sharing, right? Like the relationship between increasing intermolecular forces and decreasing intermolecular forces with like various different things is really important for this exam, um, as we've been discussing. So yeah, okay. Triglycerides. All right, so this is a kind of a bio question. So if you guys know, triglycerides have a lot of fatty acids. These are fatty acid chains. Um, and then this is like a glycerol kind of compound here. And so while it has a polar part here, most of this is in like nonpolar or hydrophobic. So hydrophobic, insoluble in water, all right? Cool, cool. Okay. Which of the following substances are considered a non-electrolyte when dissolved in water? So non-electrolyte means that it doesn't, so electrolytes, right? What that means, it's in the name, it produces charged ions, okay? So when in water, it produces charged ions. So we see here like sodium hydroxide, right? They'll produce Na plus and OH minus. Salt is going to produce Na plus and Cl minus. Sodium bicarbonate is going to produce Na plus and CO3 minus 2. Caffeine is a non-electrolyte. We have never seen an example where this would produce an ion, so that's why it's D. Okay. In an aqueous solution, of calcium nitrate, the interaction between solute and solvent particles are best described as, so ion dipole. Just because it's going to be like calcium plus 2, nitrate minus. The oxygens are going to be um, like attracted to the calcium, and the hydrogen is going to be attracted to the nitrate because there's a partial positive and partial negative. All right. So that's the ion dipole sort of interaction. All right. So we just got through the second page. Does anyone have any questions about that? Any questions about any of the questions? Okay. Yeah, I am trying to explain it as I go, but like also try to think about like the thought process I'm having too. Because in addition to just knowing the concept, it's also important to know how to like approach a question. Because these kind of questions, they can be a little tricky when you really read. Like, if I read this on the exam, I might be like, you might like get stuck on it because you're like, why is there so much like nonsense here? I didn't read like elevated link to heart disease. That's not chemistry, right? But I do know when we talking about chemical structures, I skip to the chemical structure, and then I look at the answer choices, right? So it's all about like kind of cutting out the fluff. All right. So, question 21 to 23, right? Refer to the energy diagram shown below. Okay. So, this chemical reaction is considered a. So, when you look at these reaction diagrams, if reactants are greater than products, it release energy. It's exothermic. All right. Think of like a ball, right? When you drop a ball, it releases energy in the form of kinetic energy. It's the same thing with this case, right? When the thing drops, it releases energy. Likewise, if it was like this, or that was a bad drawing. If it was like this, right, this would be exothermic. Okay. So like we see that it's increasing. So it's exothermic, so not endothermic, not endothermic. We see that there's two humps here. And so it's a two-step reaction. So the answer choice would be C. Okay. What letter refers to the transition states? That would be B and D, right? These are the tops of the hill. Okay. How many intermediates appear in the reaction? There is only one, and that's C. Okay. This is reactants and this is products. Okay. So this is a question we did in class. So we can, yeah, let's apply some of these concepts. Okay. So we see here that we have experimental data. Okay. And they're asking first for the molecularity. So what we have to do is we have to find the rate law. So this is what I did during my SI sessions. So this will be pretty helpful. Obviously, you guys can, do the math. So like let's just go through this normally and then I'll explain how I would do it on the exam. So we see here that we need to figure out two experiments that we need to use to isolate one of the concentrations. So one of these will be 2 and 3. We see that this gets doubled and this changes, right? So we could do 0.900 divided by 0.450, and then put this as some exponent equals 2.18 times 10 to the negative 2 over 5.45 times 10 to the negative 3. Okay, and so without using the calculator, I could tell that as this is going to be 2, right? Because 0.45 times 2 is 0.9. And then this is going to be around 4, right? This is just a result of me being very familiar with exponents, right? We see that this is 10 to the negative 3, and then this is 10 to the negative 2. So this is in some ways kind of like 20 in this case. Another thing you could do to make this a little bit easier to see is you can move the exponent around. So instead of it being like 2.18, you could say 21.8 times 10 to the negative 3. Now you can see that as this doubles, this also quadruples, right? And so we could say that this is going to be 2m equals 4. Yeah, just equals 4. And then we see that that's going to equal m. That we can see that m is going to equal 2 in this case. Okay? So what I just did with like kind of showing you this math without actually dividing it is essentially what I do when I just look at like the table, right? We see that as this doubles, this will quadruple. And then we could set up this equation right here and then solve for m, which is so much easier than like writing out all of this. All right. So I'm going to try to do that for the next one, just to reiterate that point. So we know that A is going to be 2. So rate equals K, and then we'll figure out B. Okay. So next one is B. So we see we're going to use experiment 3 and 4. So here we see that this will double, right? This remains constant. And we see that this doubles, right? We see that that's pretty much doubling there. So we're going to set the equation up to be 2 equals n equals, or 2 to the power of n equals 2. So n in this case will be 1. So this is the rate law. Okay. So it looked like we did a lot of work there, but I was really just taking the time to explain what we were going to do. If you just like recognize that if this is doubling, this is quadrupling and stuff, like that will probably save you some time with that. Now, if that's not something you're comfortable with, you can do it the way that he taught in class. And like, it's not going to like be the end of the world if you do that as well. Okay. But anyways, so we see that this is 3. So it's going to be term molecular. You want to make sure you memorize these prefixes because I've seen questions where he does tri-molecular and that's wrong, right? So it's ter, bi, and uni, and then quad molecular, okay? All right. So what is the rate constant? So we need to plug in the rate in this case. So let's do the first experiment. Let's say that this is going to be 6.81 times 10 to the negative 4 equals K. And then we're going to do 0.225 M. Well, the brackets already mean concentration. So me writing M with the brackets is redundant. And then 0.150. Okay. And so what we need to do is we need to divide out all these things. And so on the calculator, what I'm going to do, let me see, can I pull up the calculator on here so I can show you? I have this app called Calculate 84. Don't use this because, I mean, you can use it for some things because it kind of mimics a calculator. So this is what I'm going to do. I'm going to do 6.81 times 10 to the negative 4, okay? And then divide it and put it in parentheses. Now we're going to put a lot of things in parentheses. We're going to put 0.225, close parentheses, squared. And then we're going to put 0.150. Okay, we just put one thing in parentheses. But yeah, that's essentially what we're going to do here, right? If I write out this thing, it's going to be 6.1 times 10 to the negative 4 divided by 0.225 squared 0.15. And that should equal K. Okay, so the answer choice I got there is 0.0897, or otherwise known as 8.97 times 10 to the negative 2. Okay? And then next thing that we can do here is we can take the units here, right? So we see that the rate is mole over liter times second. And what we did is we took the concentrations and divided it. So we're going to put this like this. So mole over liter squared, and then liter times mole. Like that. Because that's essentially what's happening here. We divided it. And remember with the rules of division, with dividing something, you have to flip the fractions. And so in this case, we see that liters and liters cancel out, moles and moles cancel out, and we're left with liters squared over moles squared times Celsius, I mean, seconds, right? And so the answer choice in this case is going to be C. Okay. Yeah. Does anyone have any questions about anything I just talked about with these two questions? Okay. Yeah. If you do, let me know because this is definitely gonna be on the exam. So just keep that in mind. And it's definitely one of those questions that could be a really long time waster. But if you have the right strategies in mind or whatever, like these questions shouldn't take you so super long. Okay. I forgot to erase this. Which of the following would change the value of the rate constant in the previous question? Um, so the rate constant, the only thing that affects it really in this case, um, would be yeah, A, decreasing the temperature. Temperature is the only thing that will like affect the rate constant. Yeah. Okay. 27, what is the approximate activation energy for the chemical reaction here? So we can figure out this by looking at here. This is 35 and this is 10. So the answer is 25 kilojoules. All right, 28. So this question, there's no right answer. He did not put the right answer as any of the answer choices. So I circled on the answer key the lowest number because you're gonna get a really low number. Um, but yeah, with this question, what you need to do is you need to first be able to identify what you have. It's sodium sulfate, so it's like this. And then you're going to need to um, figure out the mole of this, and then 125 milliliters is going to be like converted to grams, which is 125 grams, and then you convert that to kilograms. And using all the different things, we have the formula delta E is equal to M like KF, and then there's I. Using that formula, we can figure it out. So let's do this. Okay. So let's figure out the moles. 57.5 times. So sodium sulfate in this case is going to. So there's 22. So I memorized like pretty much most of these atoms like molecular weights. So 22.99 times 2 plus 32.06 plus 4 times 16, right? Doesn't need to be super approximate because it's an um, multiple choice exam. Same thing with the MCAT, it's also multiple choice. So you don't need it to be super approximate. So with that in mind, we have the molar mass. So 57.5 divided by 142.04. We got this number, okay? 0.404 moles of solute. Okay. So now what we can do is we can plug in everything to figure out the delta T. So KF, oh shoot. So KF is like 0 point something. Can anyone tell me what KF is? I think it's 0.518, right? Is that right? Does anyone know what KF is? It's not a trick question. Just look at the reference table. All right, I'm gonna look up the. Mm-mm-mm. Wait a minute. There's a partial closure? Wait, what? Oh shoot. Guys, tomorrow we don't have school. Oh, um, so that means your exam is gonna be on Thursday. So what that means also is that we can have Wednesday as a SI session as well. Okay, all right, that's kind of fun. Oh, wow, wow, guys. So I just got a text. I don't know if you guys got a text. Um, yeah, it says that I don't want to is closed. Um, but remote instruction's happening. Or no, it's that, yeah, all in-person classes are suspended, but yeah, classes moving to remote instruction. Oh man. Hmm. Okay. Anyways, so with that being said, okay, so that changes some things with my own schedule. Okay. Sorry, that was a little funny. Okay. Man, you guys are so quiet. You guys could celebrate with me, Like I'm also a student here. Um, so 125 kg. That's the solvent. Let me look up the
Wait,
KF.
we're asking for KF of water?
Yeah, what's the KF for water?
1.860.
Oh, that's the KF, 1.680.
860.
Oh, okay. So I got mixed up. All right, good. Thank you.
Oh,
So KF is typically in molality, um, over Celsius. Yeah, just so you know the units. And then this is going to have a Van Hoff factor of 3. And so when we put all this into the calculator, so let's do that, we see that it's 0.404 divided by 0.125. And then take this number that we got, times it by 1.86, times it by 3, and we get around 18. So this is going to be delta t. So it's negative 18, which is delta t. Or this is going to be 18, which is delta t, but then you have to make sure you understand it's freezing point, so you have to subtract it by 0 degrees Celsius. So the answer choice here is going to be negative 18 degrees Celsius. Okay? All right, which of the following intermolecular forces is/are expected to be observed in the sample below? So we have hydrogen, like these CH3s, right? Like that's dispersion forces, and then we have a Cl, so that's a dipole. So the answer choice here is going to be C, which I had circled by accident. Okay. Which of the following substances is expected to have the lowest boiling point? So in this case, we got to figure out which one has the lowest Van Hoff factor, and this one will, because that's covalently bound. Everything else is ionically bound. All right, so this is the little half-life question. So this is a first order process. We're given the rate constant. This is a question that you will, obviously, I believe you'll have the half-life expressions, but if you don't, half-life with the first order one is very unique because it's basically just natural log of 2 over k equals t1/2. And so you can like change it around to figure out the half-life. So in this case, it's natural log of 2. So let's put this count thing in the back of the calculator. So let's do natural log of 2 divided by 3.85 times 10 to the negative 2. Okay. And I got a value around 18. And so when you say it's days inverse, that means it's going to be days. So the answer choice here would be B. All right. Okay, so I went through the third page. Does anyone have any questions about this?
okay, I have a few questions.
Yes.
For 25, why did you get C and not B with like the was it the units?
Yes, it was the units. So I showed you here like the math here with the units, right? So over here I didn't show the units here because it would be really confusing, but in this case it would be moles over liters times seconds. This is molarity, and then this is molarity, right? So molarity is mole over liter, and this is also mole over liter, okay? And so obviously, like when you do the math, you're not really looking at the units in this case, which is why on the bottom, that's why I showed the units. Anytime you have units like in the denominator, you're dividing it. And so this essentially is getting flipped, right? It gets flipped here. and then this also gets flipped. And so that's why when you cancel out the units properly, you're going to get um, liters squared over mole squared times seconds. Okay? Does this make,
Okay.
do you want me to go
Oh,
through it again or?
no, I got it now. I didn't put the square for liters per mole squared.
Oh, yeah, yeah,
Okay.
yeah. Hmm. Any other questions?
And for 36, you know how in the first module we used to like draw out the things? We don't have to do that. We could just
You,
look at that.
you don't have to do that if you can identify like these are ionic, right? Ionics usually are like things with polyatomics or with like metal and non-metal stuff. So in this case, right, we see that they all have metals and non-metals, but then this is both non-metal.
Oh, okay, thank you.
Yeah, no problem. Alrighty. Um, okay. So any other questions you have or anything else?
Nope, thank you.
Okay, sounds good. So yeah, so this question. So this question is a little bit different than other questions I've been saying. This is him, last year he taught organic chemistry, and so he wanted to take an organic chemistry question and kind of like give you guys like a little bit of a taste of like what it means. You don't need to know this reaction in detail. Any sort of paragraphs you get on the exam, you probably don't need to know in detail. And this is one of those things, right? So this is a bunch of yap. It's an organic reaction, blah, 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 right? We don't need to know that. This is important. Two means it's bimolecular. So they're already telling you the rate law. And then they say additionally that it depends on each, like the rate is dependent on each reactant, which means that the rate law has to contain both this and this. And if we know it's bimolecular, it has to be both of those things. So like this is a very like this is an exception, I guess, to what we talked about, where we need to only know the experimental or the reaction mechanism. Like if they just straight up tell us what we need to know, then we don't need to know the other two things. So for this case, right, we see here that there's two reactants here, and based off this part in the reaction thing right here, ooh, ooh, right, the concentration depends on um the rate, the reaction rate depends on the concentration of each reactant. We can conclude that the answer choice here is C. Okay. All right. Um, which of the following will likely result in an increased reaction rate? So this one would be definitely I, definitely 3, and definitely 4. So C. Decreasing concentration will not increase the reaction rate. When I think of increasing reaction rate, like they obviously talked about in the beginning of module 3 with like temperature, they talked about with surface area, they talked about with pressure. Um, And they talked about with one other thing that I forgot. Ooh, I forgot what the other one. Oh, catalyst. Yeah, catalyst. Right. But what like the way I think about increasing reaction rate is I think about collision theory. Collision theory, like we talked about in module 3, it's when reactions they with proper energy and like with sufficient energy and proper orientation, the um the reaction is supposed to, yeah, it's going to react, right? And so when you increase concentration, you increase the probability of those effective collisions occurring. And likewise, if you increase temperature or add a catalyst, those also increase those effective collisions occurring. So if you think about it like that as well, that's also really helpful. Okay. 32. If the rate constant for this reaction is experimentally found to be 3.57 times 10 to the fourth, blah, blah, blah. How long will it take for the hydroxide concentration to decrease to 0.05 molarity from initial concentration of that? So we have a couple things here. We have some time unit, right? We have a time unit here. We're asked to figure out how long something is. And we're also given uh, a final and an initial amount. And we also know it's second order. So what we need to do is we need to think about the second order equation, right? And that equation is something here equals negative KT probably plus 1 over initial, I believe. I mean, it's on the reference table, so I can just triple check. But does everyone else, can anyone like verify that this is right? So I don't need to check it. Hello.
There's no negative sign for the
No,
K.
good. Okay. Thank you for letting me know. Sounds good. So yeah, so we see that we have a final. So this is going to be the final amount, and this is the initial amount. And we have a K value of 3.57. 3.57 times 10 to the 4. And then we're trying to figure out T in this case, which can be a little confusing with a plus. Okay, so what we need to do is we need to just isolate T. So all these questions, right? The hard thing isn't so much like identifying what we need to do. The hard thing is actually just doing the math. And you're going to see that as well with like acid bases and all these other things where like the math itself, like the concept itself isn't super bad, but it's actually just applying the math questions and equations and whatever we need to do. So what we need to do here in this case is what I would do is I would try to actually figure out what this value is before I do anything. So let's just do that. So 1 divided by 0.05 is going to be probably 200, right? Oh, 20, my bad. So this is 20. This is 1 divided by 0.35 is going to be 2.8. So this is 2.8 plus 3.57 times 10 to the negative 4, or 10 to the 4 t. Okay. On the exam, make sure you write a little bit better. I'm kind of writing a little recklessly. And then now this question is so much easier to solve, right? Now that we have these values, right? So we do 20, let's do 20 minus 2.8, and we get like 17.2, 17, yikes. I really should have gave you guys more space. That's my bad, guys. Trying to conserve paper and stuff. So let's just move this here. 17.8 equals 3.57 times 10 to the 4, and then this is t, and then we divide this. So it's be 17.8 divided by 3.57 times 10 to the 4 equals t. So let's figure that out. And this answer is going to be in hours. Okay. So let's do 17.8 divided by, and then put that in parentheses, 3.57 times 10 to the 4. Okay, if you guys didn't know, like if you put parentheses like this, it'll divide out properly and it saves you a lot of time. So we got this value of t. So this is around 4.9. Why is it 4.9? Did I make a mistake somewhere? I feel like it was supposed to be 4.8, but
Was it 20 minus 2.8?
yeah, I mean, I guess like was not, oh, I put
It would be 17, yeah,
17.8.
exactly.
See, like those are little things that, I mean, you wouldn't have recognized that mistake on the exam, but it was like close enough. Um, yeah, okay, so that's 4.8. So you got 4.8 times 10 to the negative 4 hours. All right. And so some of you, you may like see that and be like, wait, that's kind of close to these values, but it's not the actual value, right? We see that this is negative 4 times 10 to the hours, right? Where this is 4.8 hours. So you need to convert this to a different value. Um, and so one thing that I would consider doing is, maybe try converting to minutes, or maybe try converting to hour or seconds. Um, the only thing is, if you converted it to minutes, you're not going to get 4.8. All right. And the reason why I'm saying that is because for every 1 hour, there's 60 minutes, right? So if I did like 1 over 60, you're not going to get 4.8 minutes if you multiply this by 60, if that makes sense. So that's why D is wrong. A is wrong. So let's try to do seconds. Of course, like if you want to check it, you can. But for every 1 hour, you're going to have 36 that like 100 seconds. And you could do that because for every 60 minutes, there's 1 hour, and for every 1 minute, there's 60 seconds. So there's 3,600 seconds. Let's take this and multiply it by 3,600, and we got 1.7. And this is going to be seconds, right? This is dimensional analysis. We did this in the first module of last year. So that's E. All right. So it was a little long, but like if you guys just make sure you like solve these things out, it's a lot simpler than it may be. And even though like I made a little mistake, I still would have gotten an answer that was pretty close to 1.7. But yeah. All righty. So for this question, all right, so we got this hexanol phase transition states, right? So we're going from solid to, we're heating up the solid to liquid, liquid heating up, and then liquid to gas, and then gas heats up. Okay, so that's always something I like to do. What is the strongest intermolecular force that can be found in the sample of one hexanol? So with itself, hydrogen bonding, boom. Okay. What occurs as one hexanol transitions from region A to region E or C? So we're going from solid to liquid to gas. And if you want, you could literally refer back to like a question that we did right here, where we went from like a liquid to gas and you increase the temperature, it heated up. So this is an endothermic sort of thing, but that wasn't even what it was asking. That's my bad. This is vaporization. So D, or sorry, no, solid to liquid. My bad. So that's A. Okay. So we see it's going from A to C. So that's solid to liquid in that case. All right. This is a long question. So I made a little typo here. This is supposed to be one hexanol. But yeah, we have to go from -20 to 175. And we're given all this information. Something you need to know is, because this might be on your exam, it says moles here. Okay. And so we have this in grams. And so we need to convert this 175 grams into moles. And we have the molar mass. So let's do that. So let's first figure out the molar mass. So 6 times 12.011 plus 14 times 0.01, just that, plus 16. Let's just do that. Yeah, everything's right here. So I got that value. Let's just figure out the moles so we can like write it on the thing. So 175 divided by 102.178. And this is the number of moles. Okay. So I would do that first just so that everything's all cleared up. So 102.178 grams per mole, or let's just do this, 1 mole over 102.178 grams. This cancels out, and we're given 1.7 mole, approximately. And so now we can do all these things, right? So we see here that it's going from -20, so it's liquid, because yeah, it's in this temperature range. So it's going to heat up to 157 degrees. So there's a liquid heating up. So we're gonna have liquid heating up, and then probably the transition between liquid to gas, and then gas heating up. All right. So there's 3 steps to this. So first step, specific heat of liquid, right? So we got, and then yes, another problem as well is this is in joules and this is in kilojoules, all right? And the answer choices are in kilojoules. So you want to make sure everything is converted to kilojoules. That's also a problem that we see. So we're going to start off with 1.7 mole, and we have kilojoules, so 240 joules over mole times Celsius. And the temperature changes from -20 to 157. So 157 minus -20 is 177. So 177 degrees Celsius, which is the delta T. Um, and we can multiply all this. And then we also have to do for every 1,000 joules, there's 1 kilojoule. Okay. And that's the first step. So let's just move this down here. This is like one of the longer questions. You're going to probably take like 5 to 10 minutes to do it, which kind of sucks. Um, unless you like practice this a lot, then you're going to be able to finish this quicker. So next is the the heat of vaporization. So that's 62 in this case. So that's 1.7 mole times 62 kilojoules per mole. Okay, and that's all we need to do there. And then the last one is um, yeah, 1.7 times same deal where now we're using the specific heat of gas. So 2.34 in where is it? Joules over mole times Celsius. And now that it's 157 to 175, we do 175 minus 157. That's 18. So 18 degrees Celsius. This is mole. And then 1 divided by 1,000. Okay. So it's a lot of stuff. I wouldn't like, like I don't think it's any like shame if you like do this in multiple steps in the calculator. So like let's just do that. 1.7. I mean, I don't really wanna, it doesn't matter if we use an actual one. So 240 times 177 times 1 divided by 1,000. Okay, that's our first one, plus 1.7 times 62. That's our second one, plus 1.7 times 2.34 times 18 times 1 divided by 1,000. And that should be the answer. Okay, so we got an answer choice around. Again, like I didn't round, so that's why, or I didn't use the exact number for 1.7, but approximately it'll be around 179 in here. So I got 178 kJ. It's really close to 179, so that's why the answer choice is D. So it's a long question. My big thing is you got to just make sure you know what you're looking for here, and once you do it, just like go like try to do it to the best of your ability. It's not that you don't know how to do it, you just have to practice, be confident, make sure you know how to do that. Yeah. All right. So this question, I got a lot of questions about this question because we didn't really do any examples like this in class. But this is definitely something he expects you to have an idea about. So we'll just talk about it. So we have this reaction mechanism here, and we just are asked to figure out the types of, we're supposed to classify these sort of things. Okay. So what we can do here, we see here that we have water that's being produced in both steps. However, yeah, in the overall reaction, there's going to be a water molecule left. So that's why 38 water is B, our product, because in the overall reaction, there's going to be water in the product side. Hydronium, or H3O plus, we see that this is consumed in the beginning and reproduced at the end. So this is not going to be the reaction. So it's either intermediate catalyst, and we know that catalysts, they are not consumed in the reaction. So we see here that it's getting reproduced at the end. So this case, this would be D. All right, and then we see here this molecule, CH3, this is an intermediate. It's getting produced and then used again. So that's why it's C. All right. Any questions about this? Did I really do a good job explaining some of these things? I feel like sometimes I trip up on my words and stuff.
I have one last question.
Yeah.
For 26, can you explain it a bit more? Because I thought it was concentration and not temperature. I was a bit confused.
Oh, with concentration? Yeah, sure. Yeah, so with the rate constant, the only thing that change like when you as you can see here, the rate constant is K, right? Rate constant here is K. So there's a difference between increasing the reaction rate and the rate constant. And the rate constant, as you can see here, right? Even though we're changing the concentrations, the rate constant actually stays the same, right? So the concentrations don't actually affect the rate constant. The only thing that actually does affect the rate constant is temperature. Does that make a little bit of sense? Like, I don't really know
Yeah.
how to
Okay.
explain
I
that.
think I mixed up the two. That's what I
Yeah,
did. Okay. Thank you.
yeah, no problem. So yeah, there's a difference between changing the like reaction rate and changing the rate constant. And the only thing that changes the rate constant is temperature.
Okay. Thank you.
Yeah, no problem. Any other questions?
For 35, were you using the Q equals MC like delta T like equations, or were you using a different one?
I was technically using Q equals MC delta T. So like this is M like C delta T. However, right, we have to modify it a little bit just because like we're not given mass, like we're not supposed to use mass, we're supposed to use the moles. So like M for this case would be mole in this case, and then I had to like adjust the temperature, like the kilojoules here. Um, like I had to convert it using like for every 1,000 joules, there's 1 kilojoule. Here is the heat of fusion, so or heat of vaporization. So like we have here MHF. This is the heat of fusion or heat of vaporization, and then this again we have to convert to moles, which is what we did here. And the last one is also MC delta T. But then again, we have to convert it to kilojoules and convert this to moles. So I just like modified it a little bit because we need to do that for this question.
Okay, got it.
Yeah, no problem. So yeah, like that's a really good question as well because there definitely will be something where you're gonna have to convert from kilojoules to joules or moles to mass or whatever you need to do. So just keep that in mind. Any other questions? Any other questions? Not like regarding the practice exam, like things you want me to go over? Anything from any of the modules?
Could you go over the reasoning for why um H30 plus was a catalyst while um 40 was intermediate?
Yeah, sure. So I'm gonna just give this like definition, right? So catalysts are compounds that are not consumed, right? That's what we learned in class. Intermediates, they're not like yeah, with intermediates, they are I don't really know a specific definition for that, but in terms of this reaction mechanism, right? Catalysts, right? All you need to know is that catalysts will be used and reproduced at the end. Okay, that's what you need to know for the reaction mechanism. Intermediates um, will be produced and reused in the mechanism. Okay, so they're like essentially opposites. Okay, and these are why catalysts and intermediates are not in the reaction, overall reaction. It's because like one is getting like used and then reproduced at the end, and then the other one is getting produced but then reused in some reaction mechanism. So they're basically like two side. They're like opposites essentially. So like we see here, like with hydronium, this is getting used in the beginning or like sometime, and it's getting reproduced at the end. There's no other places where hydronium is, and so as a result of that, that must be a catalyst because it's not like also like if you think about the reaction mechanism, right? If I were to like draw out like these steps, like the hydronium would be like somewhere here, right? And then it ends up like as a product as well, right? So it's actually affecting the overall like like it's actually acting as a catalyst in this case with um like this intermediate, right? This intermediate is going to be found here, like in the intermediate area, right? And so same thing with this intermediate. This intermediate is going to be found in this hump right here. And so it's getting produced but then reused for the next reaction. While like the hydronium is getting used up in the beginning and then like reproduced at the end. Does that make a little bit of sense?
Yes.
Yeah. So again, you can always ask me more questions about that. Because I know he didn't really explain that well, but you can see he's literally re-asking, like asking this on last year's exam. So keep that in mind. Because it's not, yeah, just keep it in mind because yeah, yeah, it's just basically opposites. So like intermediates, we know it's going to be like produced and then reused. Like catalysts are something that's used in the beginning and then reproduced at the end. Okay. So yeah. All right. Any other questions or anything?
Oh, wait, I have a question. This might be really dumb, but remember how last year we did something similar, and like we crossed out the molecule that was like found on both sides of the arrow? Like, why
Yeah.
didn't we cross it out here? Because it was like it's on one side, but it's also on the other.
Yeah, we know we can do that as well. So like we could cross out things like this. But what we'll get is we'll just get the overall reaction, right? So we see here that when we cross everything out, we're getting like CH3 to CHOH. And then we see that plus CH3, CH2, and then plus H2O. Sorry, it's supposed to be like that.
So
Okay, so
how do
like,
we know that the H3O is a catalyst and not none of the above? It's like gone, is what I was confused about a little bit.
well, usually, yeah, none of the, yeah, um, he didn't, yeah, so don't usually, yeah, it's just a matter of like knowing what a catalyst is in the context of a reaction mechanism. Like he did not really explain that well, but basically, yeah, like it is something that is used in the beginning or some point in the reaction that's reproduced at the end. That's why it's never consumed because it's always produced in an equal quantity to when it like was used, essentially. So like the big thing is like catalysts are compounds that are not consumed. That's like the definition we talked about in like module 3 for catalysts. So they're not something that's like in the reaction mechanism. It's something that like creates a new pathway, lowers the activation energy. But in the case of reaction mechanisms, there's just something, all you have to know is that it's something that's used and then reproduced at the end. I know it's a little annoying that I'm like kind of reiterating that point, but just keep that like idea in mind for like the exam. You
Okay,
don't
thank
need to,
you.
yeah, you don't need to know it like too much in depth. I don't really think you'd ever get like a answer choice that's like none of the above unless it's like some compound that's just not like I don't know, like they might just put like CH3OH, right? Like that's like not in this question. So like that's none of the above. But I don't think you would ever like there would ever be a compound in here that would be none of the above, if that makes sense.
Okay, thank you.
Yeah. Yeah, like none of these compounds would never be none of the above. Like these are all something that's like in the reaction, whether it's an intermediate, a product, a reactant, or a catalyst. So yeah. Okay. Any other questions?
So would CH3 to CHOH 2 plus, like the thing produced in the first reaction that's also used in the second reaction, also be an intermediate?
Yes,
Okay.
exactly. Very good. Yeah.
And then everything else that's left over after you cancel is reactant and product?
Right.
Okay.
So the only thing that's like slightly different is hydronium, which is going to be a catalyst in this case. So it's like the opposite of the intermediate. if that makes sense. Okay. Any other questions? Hmm. So I just see here that Professor Yusuf said that the exam will be held on Thursday. So you guys will have an extra day. On Wednesday, we'll probably be in person, so I'll be able to meet you guys there as well. So it's good. I hope I don't have microbiome tomorrow. Uh, hopefully, I really hope I don't have microbiome disease. Okay. Anyways, does anyone have any other questions or anything like that?
Oh, I have a question that's not about chemistry.
Sure. What's the question about? Is it
W-
about anatomy?
Yeah, we have it on
Oh God.
Wednesday.
Uh-huh.
Um, you know how she says to do practice questions? And I was looking, I didn't know what like question would be similar to how she does it. And I couldn't find any. And I was like, what if I found some, but it wasn't like how her tests are like? Do you have any tips on that?
Um, honestly, like I know she says do practice questions, but um, yeah, she's not giving you a good resource. I honestly would say the best course of action would be to just like really primarily focus on those review slides.
Okay.
Those review slides, like the bolded stuff in the review slides were are like definitely questions she will ask.
Okay.
Like she made the exam and then created those review slides. You know what I
Mm,
mean? So like
okay.
she literally like cross-referenced and bolded whatever you need to know. So
Okay. Okay,
yeah,
that makes sense. Okay, thank you.
yeah, no problem. Yeah. Any other questions? All right. Are you guys feeling good that like um, you know, there's no school anymore or anything like that?
Yes, because now I have more time to study for anatomy.
Nice. That's good. That's good. All right. Well, I guess I will you know, say goodbye to you guys. You guys will obviously you guys have tomorrow now to study. Yeah, I don't even know if like is Professor Yusuf even teaching tomorrow? Like, is he gonna do remote?
No, he canceled it. He said we're just gonna have an extra time to study.
Wow, look at that. That is very nice. So, okay, that's interesting too. You guys are gonna be a little behind, but um, yeah. So you guys have Tuesday to study. You have Wednesday to study. So you guys can reach out to me. Let me know if you have questions or anything like that. Um, oh, I didn't see Devinder's questions. I'm so sorry. Um, yeah, I could not see the chat. Devinder, do you want me to go over that quickly or?
No, it's okay. You answered him. Thank you, though.
Okay, sounds good. Sorry about that. Um, then yeah. Okay, so I'll do a review session on Wednesday as well, and that will be in person, 9:30 to 11. All right. Any other questions or anything like that? You guys want to shout out to me or anything?
Hey Luke, how was your day?
Oh, hey, Ola, my day was good. I was shoveling. I live on a three-sided house, so like I had to
Oh,
shovel three sides. So I'm really tired.
Aw,
But
Oh,
you should take a nap.
Luke, if we were there, we would have helped you.
really, thanks, guys. Thanks. Appreciate it. Appreciate it. But man, I kind of am annoyed that there's no school tomorrow, but I'm also kind of happy because I was gonna have a lab tomorrow, but I just don't like that lab.
That's real.
So I'm so happy.
Well, have a good snow day and thank you so much.
See you,
Yeah,
Luke.
no problem. Have a good day, guys. See
Bye.
you. Peace. Yeah, have a good day, you guys, as well. If you guys have, do you guys have any other questions or no?
no, thank you so much.
All right, bye,
Have a
Amina. Have a
good
good
day.
day.
You
Bye
too.
bye.
Oh wait, sorry.
Yeah, no
Wait,
problem.
just in general for anatomy, if I only study the bolded parts for the test, do you think it would be beneficial to also study the other things just in general for the MCAT? Like, did you feel okay just knowing the bolded stuff on her tests?
In all honesty, like okay, so I obviously took anatomy after the MCAT. And what I can
Oh,
tell
okay.
you is that the anatomy, like anatomy is not very vital for the MCAT. It's more physiology that you'll need to know more. Um, just like it's just that, it's like properly it's correct if you learn the anatomy first and then like structure before function. Um, but yeah, like you don't really need to like go into the details. I think it's better
Okay.
to just try to get that A and then take physiology and learn all that stuff.
Okay. Sounds great.
Yeah,
Thank
you got this.
you.
You got this. Have a good day.
Bye.
Bye bye.